Welcome. What's going on, everybody? We have probability now. We're starting chapter 9. Our first section, our first lesson is probability of simple events. So let's talk a little bit about probability. It's something that you meet with often in your life, your everyday life. What's the probability that you are done with school and just looking forward to the summer? 100%. What's the probability that your sibling will annoy you today? Well, depends, but I'm guessing that's somewhere around the vicinity of like 80 to 90% chance. Uh, what is the percent that, or what's the probability that you will really love following along these math notes? That's probably down around, what would you say, like 20%? 20% chance, maybe lower. All right, so let's get started. I want to have this little conversation before we get started, or before we jump into the notes. I want to outline 3 words that we'll be discussing. Experiment, an experiment when we're talking about probability. All right, an experiment is just an action that you do that has different possible, that kind of brings us to our next word, outcome. So experiment, for instance, rolling a die would be a classic probability experiment. All right, another one might be flipping a coin, or another one could be pulling a card out of a deck of cards. All right, that's the experiment, the actual action. Okay, the next word that comes up is outcomes. So these are all the possibilities that could happen in an experiment. All right, so if we take our example and say, well, we're rolling a die, that's our experiment. An outcome could be you roll a 1, or another outcome you roll a 2, or another outcome you roll a 3, or roll a 4, or roll a 5, or roll a 6. Or your little brother grabs the die before it stops, runs away, throws it out the door, and you guys can't find it anymore. That is a possible outcome. But we can't really find the probability of that specifically. It doesn't really work for our lesson today. So let's just forget that one. So this, how many outcomes does this have? It has 6 outcomes. If you write down all the outcomes of an experiment, then you have what we call, oops, I did the wrong type of bracket. We have what you call the sample space. All right, so the sample space is when you write down all the possible outcomes for an experiment. Now, I've gotten confused in the past because I've never really researched it, but it always tripped me up when I try to talk about it with students because I kind of use words as synonyms, use them interchangeably, and I think it confused students, and I think it confused me sometimes. So I want to make this distinction. So an event, this next word here, event, I would say like, oh, the event is rolling a die. No, the event is a certain number of the outcomes that you're looking to achieve in the experiment. Okay, and you can find a probability for an event. So an event is, for instance, rolling only positive numbers. All right, so rolling only positive numbers. So what would the positive numbers be? They would be 2, 4, 6. All right, so an event is a collection, a small group of the outcomes that you're trying to get in the experiment. All right, so the event you're looking to do is roll positive numbers, and the outcomes are all the possible outcomes, or all the different possible things that could happen in an experiment, and the experiment is the actual action that you're doing. Okay, so if we want to find the probability of this event rolling a positive number, we count up 1, 2, 3. We count up the successful outcomes, 3, and we put it over the total outcomes, 1, 2, 3, 4, 5, 6. All right, and then we have our probability of rolling a positive number, and that could be simplified down to 1/2. You know that that's 50%. as a decimal, or 0.5 as a as a percent, and then 0.5 as a decimal. Okay, so we put the favorable outcomes for our event, the thing that we're trying to achieve within this experiment, over the total possible outcomes. All right, so these are the three things that we need to straighten out in our head. The experiment is the actual action. The outcomes are the possible things that could happen when you complete that experiment or action. And then the event are just a small group of the outcomes that you're looking to get in this experiment, that you're looking that would mean that you've been successful in your attempt. Okay, so for instance, if I flip a coin, okay, that's your experiment. All right, then let's say I say choose heads or tails, and you say heads. Okay, heads is the event. You want to get the heads, right? And then the outcomes that are possible are heads and tails. So the chance of getting a heads is 1 out of how many? So out of how many total outcomes will heads or tails? 2. So then you have a 50% chance. Okay, so that is our not so brief, not as brief as I thought, introduction to probability. And we wanted to clarify those 3 words: experiment, outcome, and event. Now here, your book starts to do it here. Probability is the chance that some event will occur. Okay, an event within an experiment, right? Experiment is the overarching action, and an event is part of that action, like a part of the outcomes of that action. Okay, a simple event is one outcome or a collection of outcomes. So for instance, like we did over here, we could have done this event that we chose, roll a positive number, has 3 outcomes. So, right, so that would be what we call a collection of outcomes. Or we could also have an event that's just 1 outcome. For instance, if I said my event was to roll a 6. Actually, to roll a 4 would be even cooler because that's my favorite number. All right, so let's say my event this time is to roll a 4. All right, all the outcomes, there's 6 total outcomes, but only one of those outcomes, one of the sides of the die, is a 4. Right, so that the chance of getting a 4, the probability of getting that event that I'm looking for, is 1 out of 6 in this case. Okay, so what is an outcome? Well, in the math definition, possible result in a probability experiment, possible results. All right, in our definition, we might say something like, what could happen? All right, the outcomes of me making a video for class. One outcome could be I make the video smoothly without any interruptions. Another outcome could be that my daughter knocks on the door and tries to open it and yells out there right now, trying to find me. And I'm not able to finish the video. There's a high likelihood of that. Or high probability. All right, we're moving on. This I don't like this example, so we're going to go to the next page. Move along with me, and I hopefully you're writing down notes and doing what it takes to clarify and understand this lesson. Probability. Here we go. The key concept. You can put a little star here. This is helpful. Number of favorable outcomes versus the number of possible outcomes. My daughter just started singing a couple weeks ago in this beautiful voice where she makes her voice go as high as possible and just continues to do that note over and over again. I think I can thank Elsa from Frozen for teaching her that. Whew, hurts a little bit. All right. The probability of an event is a ratio. So ratio we can write in fraction form, which is going to be how we're going to set up all of our probabilities in this lesson. That compares the number of favorable outcomes to the number of possible outcomes. All right, now this little chart here is a really important chart. I actually just added it to your vocabulary. But this is something that you'll want to star. Today, when it asks you to tell how likely something is, okay, if it's 0, it's impossible. If it's 1 or 100%, that's certain it's going to happen. And then in the middle is 50%. That's as likely to happen as not. Okay, those are your 3 kind of unchanging percents. If it hits any of those exactly, then you put this word down. But anywhere in between these, okay, if it's down here between 0 and 50, somewhere between 0 and 50, it's going to be unlikely. And anywhere between 50 and 100, it's going to be more likely than not, okay, to happen. So we'll deal with that and do some examples of those. Outcomes occur at random if each outcome is equally likely to occur. So, for instance, if you're flipping a coin, it is equally likely that you'll get a heads versus a tail. So those events happen randomly. All right. So we have our first example. There are 6 equally likely outcomes if a number cube with 6 sides labeled 1 through 6 is rolled. All right, so 6 sides, each numbered differently, 1, 2, 3, 4, 5, 6. There's only 1 6. Oh, okay, so here is our event. This is the event right here. This is the event that we're trying to find the probability for. All right. Oops, that's not what I was meaning to point at. This is the event. All right, what are we trying to find? We're trying to find the probability of getting a 6. All right, so that's our event. We're trying to get a 6 when we roll a die. The rolling of the die is the experiment. The event is getting a 6. And now we're trying to find the probability of that. So we find the number of possible outcomes, right? You can get a 1, 2, 3, 4, 5, or 6. So there's 6 possible outcomes. We put that on the bottom. And how many of those outcomes are our successful outcomes that relate to our event? There's only 1 6 on a number cube. So that we put on top. And we get a 1 6. Now, it does want us to also write it in percent form and decimal form. So what I suggest is that you put the top dog in the doghouse. So right, top dog for 1 6, right, goes in the doghouse, and then we divide. We can do long division. You can also just do 1 divided by 6 on your calculator, and that should come to 0.16666, and then cut it and just change it to 0.17, and then we have move the decimal over twice or multiply it by 100 to get the 17%. Okay, that was quick. All right, now try this one on your own and then check it out. A coin is tossed. Find the probability of the coin landing on heads. Write your answer as a fraction, percent, and decimal. All right, well, we know that there are 2 possible outcomes. That goes on the bottom. And our favorable outcomes that we're looking for, it says, what's the probability of landing on a heads? So that's our event. So how many of those outcomes are heads? 1. So 1 out of 2 chance, which gives us 0.5 as a decimal and 50%. So there is our probability of that simple event occurring. Number 2, find the probability of rolling a 2, a 3, or a 4. Sorry about that. Or a 4 on the number cube. All right, and so what do we want to do? Here is our probability notation right here. The P just stands for probability of, and then the event is listed inside, getting a 2, a 3, or a 4. And so we have a total possible outcomes on the number cube. We still have 6. That goes down here. And then we have 3 of those 6 outcomes are our successful outcomes or our favorable outcomes. 1, 2, 3. And so we are going to put the 3 over the 6 and get 1/2. And then we know that 1/2 as a decimal is 0.5 and 1/2 as a percent is 50%. So let's try this. Got it. Pause the video. Try these 3 and see if you can get each of these in fraction, percent, and decimal form. Then unpause and let's see if you can get the answers. See if you got the answers correct. Here we go. Okay, so what does this say? This is our event right here that we're trying to find the probability of. It says probability of spinning an F. Well, we have equally likely outcomes over here at this spinner because each of the pie pieces is the same size. So let's pretend like we spin it. Well, how many outcomes, how many possible ways could this spinner land? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible outcomes. So that goes on the bottom of our fraction. And then we want to figure out how many favorable outcomes of those 10 are there. And favorable is defined right here. We're looking for F. So we have just the F right there. So we have 1 favorable outcome out of 10. So we can divide that and get 0.1, and then that would be 10%. All right, now let's go on to see probability of D or G. So again, we still have the same number of total possible outcomes. And let's see how many pie pieces are taken up by D or G. So if we go around, we have D here, I have G here. So that shows me that 2 out of those 10, or 1/5, are 1/5 of them are D or G. And then if we divide, we get 0.2, which would equal 20%. All right, 20% chance that we could land on a D or a G. And now we're going with the probability for part D. We're doing probability of getting a vowel. If you don't know what the vowels are A, E, I, O, or U, and sometimes Y. Okay, A, E, I, O, or U. So let's check this out and see how many of these possible outcomes are A, E, I, O, or U. So we have the A here, we have the E here, and we have the I here. Now, there's no O's or U's, so that doesn't count in here. We're not going to write 5 just because O and U are vowels. They actually have to be on our spinner. So 1, 2, 3, there's 3 favorable outcomes over 10 total possible outcomes for this experiment. And so that gives us a decimal of 0.3 and a percent of 30%. All right. So hopefully you did okay there. And if you didn't, let me know, email me or contact me somehow to ask questions if you need to. All right. So that's simple probability. The favorable outcomes over the total possible outcomes. And this is a part that can confuse people, but it hopefully it's really a simple aspect. If you don't overcomplicate it, then it shouldn't be that hard. Okay, complementary events are 2 events in which either one or the other must happen. Okay, either one or the other must happen. So when you flip a coin, the complementary events are heads and tails because one of those has to happen. There's no other outcome. Okay, so complementary events, it's either heads or tails. All right, one's 50%, the other's 50%. They add up to 100% when you add them together, so they are complementary events. If you think of rolling a die, 1 would be one event, and its complementary event would be not getting a 1. That's weird, right? So there's a 1/6 chance of getting a 1 and a 5/6 chance of not getting a 1. So those are complementary events. So for instance, you could say probability of getting a 1 and the probability of not getting a 1. Those are complementary events because, right, they add up to 100%. Because that's the only possibility. You either get a 1 or you don't get a 1. So those are complementary events. You could say it another way. You could say it like probability of getting a 1 and probability of getting a 2, 3, 4, 5, or 6. Right? Or you can just simply say probability of 1 and probability of not a 1. Whew. All right. So here we go. The probability of not rolling a 6. Find the probability of not rolling a 6. Okay. Now, this is doing it. In this case, they show the idea of comparing it to example 1. And they're thinking, you would think, oh, well, if the probability of getting a 6 is 1/6, then what's left? What's the complement? Well, that'd be 5/6. So if the probability is 1/6, well, then it has to add up to get to 1. So what would add to 1/6 to get 1? Well, 5/6 would, because that equals 6/6, which gives you the 1 whole. Okay, so that's talking about the complement. So let's look at this got it and work through it. A bag contains 5 blue, 8 red, and 7 green marbles. A marble is selected at random. Find the probability the marble is not red. So our experiment is picking a marble out of a bag. Okay, the event that we're looking to find, the event that we're looking to achieve, is we want to find the probability of the marble is not red. All right. So first we have to find the total possible outcomes. In this case, you might think there's 3 outcomes because you can either get blue, red, or green, but we actually have to account for how many of each there are. So we actually have to get the total possible outcomes, we actually have to do 5 plus 8 plus 7. All right, because each of the different 5 blue marbles count as a different possible outcome. All right, so we're going to add those up. That comes to 20. All right, now we know that the bottom of our fraction is going to be 20. And in this case, I think they suggest that we do the probability of red first, what that equals, and then we figure out not red by finding the complement, right? What the complementary event would be. So if I say, what's the probability of getting red? Well, I have 8 red, so that's 8 out of 20. So then they're saying, well, 8/20 plus what equals 1 whole? All right, well, then we would say, well, 12/20 would add to 8/20 to get you 20/20, and that gives you the 1. Okay, so the probability of not red, right, the complement of getting red is 12/20, which would be the same as if we divide that by both by 4, would be 3/5, and that would be 6.6 or 60%. Okay, you could also just say, oh, wait a minute, just add up the things that are not red and find that probability. So we look at the blue, we look at the green, and we say, well, not red is blue and green. So just add the 5 and the 7 and get the 12, and out of total, how many total possible outcomes? 20. So then we get the 12/20 that way as well. Okay, so you can do it either way, but the idea is to think about complementary events a little bit there. All right, example 4, we're almost there. We are looking at Mr. Harada. Surveyed his class and discovered that 30% of his students have blue eyes. Identify the complement of this event. All right, well, here we go. We have the probability of blue eyes. What's the complement? Well, the complement is the opposite of blue eyes, which would be not blue eyes. So the complements always have to add up to 100% or 1 whole. Since the probability of getting blue eyes is 30%, then that means the probability of the opposite, the complement here, probability of not blue eyes, would have to be 70, because 30 plus 70 is 100. Okay? And then they just change it into the decimal and percent forms. Decimal and fraction forms. Okay? All right. Good work. You can practice on the guided practice and the independent practice and let me know how you do. Okay. Good work. That was a long one, but hopefully it clarifies things and sets us up with a good foundation for the rest of the chapter.